introduction. My presentation title is Application of AI in Agricultural Machinery, Maintenance and Diagnostic. Here are some basic information of me. I'm a mechanical engineer and I'm starting my PhD studies in 2024. My supervisor is in the middle. He's Mr. Sándor Pálinkás, and we are from the University of Debrecen of the Department of Mechanical Engineering from Hungary. And my title of my PhD is Application of Artificial Intelligence Methods for the Investigation of Thermal Spraying Technologies. So briefly, I would like to introduce my previous research, what was made during my MSc study, master studies, to understand why are we doing right with this. So the efficiency of agricultural activities is significantly influenced by the condition of the power and work machinery used in agricultural production, and creating and maintaining the proper soil conditions play a crucial role in achieving the desired crop yields. Soil cultivation tools are subjected to substantial stress during agricultural operations, which can lead to significant wear and tears. On the picture, we can see used tools which used in agricultural machinery. At the top, we can see the stalk cutting knife. At the left hand, there is a disc of the corn harvester, and at the right hand, we can see the time which used on combinators. Hot metal spray fusing technology, what we used at this previous process. Hot metal spraying is a surface repair process that is widely used in today's technology. During the method, the metal powder is heated and sprayed onto the surface to be repaired at high pressure, thus providing excellent adhesion and corrosion resistance. But it is widely known. The advantages of the hot metal spraying include speed, durability, cost efficiency, making this technology widely chosen for the surface repairs. Oh, and here is the cultivator time, which is sprayed by hot metal powder by us. And at this point, we made some specimens. So we created 8 test specimens, which were coated by different kind of alloy powders like Eutalloy alloy powders, N60 Mogul alloy powders, and 50% Mogul and 50% Kunstgram carbide alloy powders. And additionally, we made 2 other specimens which were made by laser cladding technology. And we made, after the coating, we made laser remelting with this layer. And we realized when we checked the layer that it's much harder than it was expected. So we created a bit better surface than it was expected by the powder. Here is the laser, what we use for remelting, and here is a specimen where we find the right temperature and feed speed for the laser. And that was the point when we realized that we had to check how this layer build up. So this is my basically the research what we are doing. We aim to examine the wear resistance of the applied coating using AI in order to predict the tool life. Currently, I'm writing a review article on AI-based predictive maintenance in agriculture, and we are trying to focus on integrating artificial intelligence and agricultural informatics into machinery diagnostic. We are studying machine learning models such as the random forest, LSTM, neural network, and extreme gradient boosting. And we are focusing mainly to explore digital twins for real-time simulations, sensor networks for data collection, and explainable AI techniques for transparent decision making. The progress in 2025 and 26, we are trying to focus this to reviewing the literature. We have to understand AI and machine learning techniques, and we are trying to replicating their prediction models. In this review, I tried to find every part of the predictive maintenance and machine diagnostic, which used in agricultural fields. So here is a list of machine which use different kind of AI, sensors, which used by the AI models. Basically, at the literature review, I find that at the tractors we can check the vibration temperatures. Combine harvesters mainly use noise and vibration sensors. Vaporizers use pressure control profile sensors. Seeders are motor and torque sensors, and the irrigators checking the flows mainly. And here we can see what kind of AI models it is used by this. At the next point, I started to check the wear detection and abrasive damage prediction using by AI, which are already used. So here are the methods: the CNN neural network, LSTM, XGBoost, digital twins, plus AI, and XAI as well. And there are here we can see the applications and the advantages of them. And next we can I made a comparison of AI algorithm in agricultural engineering, like what are the used algorithms which we can use, and there are benefits of them and there are limits of them. And I would like to highlight the limits of these algorithms, which are in the middle. So the random forest is here. Slow prediction, not scalable well. Support vector machine, like weak in big data, not easy to interpret. And the CNN has the data intensive, long teaching time. The LSTM, the teaching is complex, a lot of memory is necessary. The XGBoost lacks explanatory. The reinforcement learning, the RL, high simulation demand, low learning speed. And the explainable AI has work only with other models. So these are the limits. And I would like to highlight what is the benefit of this research. We aim to develop an AI-based model that determines the degree of wear on agricultural tool surface using photographs and 3D scans. This can enable us accurate prediction of the remaining service life and the amount of agricultural field the tools can still cultivate. By selecting the optimal coating quality and considering soil type and soil hardness, companies and farmers can precisely plan the maintenance activities. This prevent them in season and downtime, allowing machinery to be serviced during winter, for example. So the winter period when equipment is not in use, resulting in reduced cost and increased operational efficiency. And we have goals for next years. Our goal is to create and test surface-treated parts under controlled wear conditions. We will scan the worn surface in high detail using 3D scanning and imaging tools. These digital images will help us to train deep learning models to recognize and classify different kind of wear patterns, predict how wear will develop over time, detect early signs of unusual or rapid wear, and this will help us to build an AI-based system for predictive maintenance in agricultural machines, making them more reliable and reducing the breakdowns. And thank you for your attention.